Hello, Year 11s. Here we are back with paper 2. All right, question 1. The diagram shows patterns made with sticks. So the first pattern has 4 sticks on it, and then the next one adds in another one here, here, and there, which is 3 more sticks. And then the next pattern adds on another 3 sticks as well. So draw the 4th pattern. So we're going to start with, the 3rd pattern. So 1, 2, 3. 1, 2, 3, 1, 2, 3. There's the 3rd pattern. The 4th pattern is going to be another stick this way and that way. Okay, any version of that, you should have 4 squares being made. 1, 2, 3, 4. You don't have to write that down though. All right, I would do this one by writing out the sequence for how many sticks are in pattern 6. So this first pattern has 4 sticks, and then 7, and then 10, and this one has 13. So I would look at that pattern: 4, 7, 10, 13. That's going up by 3 each time, so 16, 19, 22. And they want to know how many is in pattern 6. 1, 2, 3, 4, 5, 6. There we go, 19. There are other ways to do that. You could continue to draw the pattern, but I like to count, figure out what the sequence is. Question 2 is asking us about some coordinates. Points A and B are shown on the centimeter grid. Write down the coordinates of B. So here's B over here, and we go across to 5, and then we also go up to 5. So 5 and 5. For part B, they want us to write down the coordinates of the midpoint. So they want to know what is in the middle of A and B. So here's A and here's B. Now this one is quite nice because you can just look at it and notice that this is the exact middle, which is 1, 2 squares away from there, and 1, 2 squares away from there. So here is our midpoint right there, and that is 3 across and 5 up. So 3 and 5 is going to be our answer. For question 3, we need to list out some different possibilities. When a spinner is spun, it shows either blue, green, red, or white. When a coin is tossed, it shows either heads or tails. The spinner is spun and the coin is tossed. Complete the list of possible outcomes. One has been done for you. So they started with B and H there. So I'm going to go with B and T. So it could be blue, tails. Then they're going to move over to green, and I'm going to keep this order, and I'm going to go green H and green tails. So G, H, and G, T. Then we have red, and I'm going to go with red heads and red tails. And then lastly, white, so white heads and white tails. I think it's easier if you kind of find like a pattern there, but that's just, again, that's a personal preference for me. Part B, what fraction of the possible outcomes contain the color green? Well, this one has green, and so does this one. So that is going to be 2 out of 8. And I'm struggling to write the answer because the controls are right over the answer line. So 2 out of 8, which you can simplify to 1 out of 4, but you don't have to. 2 out of 8 is all we're looking for. All right, question 4, we have some number machines. Here is a number machine. You input something, you times by 2, you plus 1, and you get the output. Work out the output when the input is 12. So if we put in 12 here, what comes out at the end? 12 times by 2 is going to give us 24, and then 24 plus 1 more is going to give us 25. Work out the input when the output is 49. Okay, so they're saying if we put in 49 here, what comes back at the beginning? Well, this time we have to go backwards, so we have to do the opposite of everything. So 49 minus 1 is 48, and the reason I minus 1 because I had to do the opposite of plus 1, and then 48 divided by 2, because the opposite of times 2 is divide, is going to give me 24. Okay, there we go. And lastly, complete this number machine. So we have 7 and then something divided by 2 gives us 9. All right, let's see how we can look at this. So I'm going to write it like this. 7, and then we don't know what happens. and then we divide by 2, and we end up with 9. So what happens if we work backwards? So what if we do 9 times by 2? That gives us 18, and so we essentially end up with, let's try to move this and give us some more space, 18, and then something makes 7. So that's going to be take away 11. So take away? Oh yes, that's going to be take away, but then we have to do the opposite of that, which is going to be plus 11. All right, let's double check. So we start with 7, we add 11, and that gives us 18, and then 18 divided by 2 gives us 9. Yes, that is exactly what we're looking for. All right, question 5, complete the table. If you've been in my class before, you know that I'm always constantly asking about these, and this is one of the reasons why. But this time they were very nice because they let you do this with a calculator as well. I want you to be able to do this without a calculator as well. So a fraction, 1/4, that's 0.25 as a decimal, or 25% as a percentage. 2/5, you could obviously just put that into your calculator, but that is the same as 4/10, which is going to give us 0.4 as a decimal. And then 0.9 or 90% is the same as 9 out of 10. All right, and then part B is a part that I don't think many people like, and the reason why is because I don't think we like turning fractions into percentages, even if we had a calculator. So what percentage of this grade is shaded? 5 squares are shaded in. There is 25 altogether. Now, if I had a calculator, I could just put that in and then click times by 100. So I could type in 5 divided by 25 times by 100 in my calculator, and it would give me an answer, either of those. But 5 out of 25, I can just make this out of 100 because percentages are out of 100. So this is going to be times by 4, and the same with the top over here. So it's going to be 20 out of 100, which is 20%. Question 6, I do think that this was generally well answered. Which metric unit would be most suitable for each measurement? The weight of a teenage boy, those people normally weigh kgs. The weight of a packet of crisps. Have you ever looked at a packet of crisps? They are in grams, because even if it's a big packet, it's got to weigh a lot to weigh a kg. Now, the weight of a bus, that's very, very heavy. That is in tons. I suppose it could be in kgs, but it's probably a lot of kgs, so we would call it tons. Question 7 is a huge question, as in you get a lot of marks for this one, and I think with the papers that I marked, a lot of people were on the right track, but didn't quite get all the answers that they needed. So Liz is buying a new car, and she's selling her old car. There's 3 offers for the same model of new car. So offer 1 is the new car is £10,599. If her old car is given to the garage, they're going to take off £3,375. The offer 2 is the new car is more expensive, 11,100, but if she gives her old car to the garage, she gets 1/3 off. Now that 1/3 off definitely messed up a few people that I saw. And then she has offer 3, which is the new car is substantially cheaper, 9,600, but if her old car is given to the garage, she gets 25% off. Which offer is best? Okay, most people did really well at figuring out what was offer 1. So offer 1 is just going to be 10,599 minus 3,375. All right, I'm going to grab my phone. No, I'm going to grab my calculator because I don't have that here. 1 second. So that is going to give us 7,224 pounds. And like I said, that one was generally well answered. Some people who were really successful also wrote down the prices beside the offer so it was easier to see. All right, then we have offer 2. So the new car is 11,100 pounds, but she gets 1/3 off. Okay, so 1/3 of 11,100 is 11,100 divided by 3, 11100 divided by 3, which is 3,700 pounds. Now that is how much she gets off. So we need to subtract that. So we have 11,100 minus 3,700, 11100. And this car from offer 2 is 7,400. So that is looking a little bit expensive at the moment. All right, and then we have offer 3 where we need 25% off of. So 25% of, because that's how this always starts, 25% of 9,600. So I'm going to do my calculator 0.25 times 9,600 because it is a calculator paper. That's going to give us 2,400. But again, this is off of, so 9,600 minus 2,400. I'm sure I could subtract that, but I'm not going to. All right, and that is 7,200. So of those 3 prices there, which one is the best offer? And that is going to be offer 3. So which is her best offer? 3. Oh wait, I can do this. I figured something out. I can go like this, offer 3. There we go. Finally. It's only taken me like 4 years to figure that one out, but that's it. All right, question 8. Luke buys 4 apples and 5 bananas. The total cost is £3.70. Each apple costs 35p. Work out the cost in pence of each banana. Okay, so he buys 4 apples. So 4 times by 35p is going to be 140 pence. I'm going to work in pence because I think it's a little bit easier. The total is £3.70. So it's £3.70 is 370 pence, and then we're going to subtract off the £1.40, so that's going to give us 230 pence. So 230 pence is how much the 5 bananas cost. And now we want to work out how much is just one of those. So 230 divided by 5. That is going to give us 46p. There we go, 46. I like that question. Question 9 is not particularly challenging, but it is worded in a very, very odd way. Let's see what they have to say. The square of a whole number is a 2-digit number. Okay, work out the smallest number that could have been squared and the largest number that could have been squared. All right, let's see what happens here. So let's take some numbers and we'll square them. So the square of a whole number, so like 1 squared is 1, and 2 squared is 4, and so on. So I'm going to keep on writing down my square numbers. So 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. I'm just going to double check those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, okay. So the square of a whole number is a 2-digit number, which means it can't be this number or this number or this number because those are single digits, and it can't be 100 because that's a 3-digit number. So it has to be one of those blue numbers that's left over. Work out the smallest number that could have been squared, so that would be whatever gives us 16, and the largest number that could have been squared, which is going to give us 81. Well, 4 squared is 16, and 9 squared is 81. So the smallest number that could have been squared would be 4, and the largest number that can be squared is 9. And then for part B, a lot of people seem to forget that they had a calculator, or they just didn't pay attention to their calculator. So they want to know which value is larger, 0.8 squared or 0.3. There are loads of people who actually did work this out. So 0.8 squared is 0.64, and 0.8 cubed, 0.8 to the power of 3, is 0.512. Lots of people had this and then still tick the wrong box. Remember, when we compare decimals, they have to have the same amount of decimal places. This has 1, 2, 3, so we have to make sure that this one also has 3 decimal places by adding a 0. So now we're trying to compare 640 and 512. Which of those is larger? And that's going to be 640, which means 0.8 squared is the larger one. So tick a box, 0.8, and then if you had that kind of working out, you should have gotten a mark for that. And I would say because 0.64 is bigger than 0.512. That's what I would do, especially because I had my calculator. All right, question 10. Lucas spends 71p and he pays the exact amount with 4 coins. What is the modal value of the coins? You must show your working. Okay, so he's got some 4 coins. So I don't know, maybe he's got like a 20p, a 20p, a 20p, and a 1p. All right, if those were the coins that he'd have, then obviously we can see there's 3 20s, so that would be the mode. Okay, we can't make up new coins like a 30p coin because that doesn't exist, so that's not going to work out. So he's got exactly 4 coins, and we need to figure out how much he has. I'm going to go with, I'm going to try to get as close to 70p as possible. So I'm going to start with 50p. If we go to 20 next, that's going to bring me to 70, which I'm way too close to 71. So what's a little bit smaller than 20p? That would be 10p. So 50 plus 10 is 60p, plus another 10p is going to give us to 70p, and then we need one more to bring us to 71. So those are the 4 coins that he has: a 50p coin, a 10p, a 10p, and a 1p. So what's the modal value? That's going to be 10 pence. There we go, because there's 2 of those, and that's it. For part B, there was more answers to this than I thought there was going to be. It was kind of a hit or miss as to whether or not people got it correct, though. A, B, and C are sets of 3 cards. Set B has the same total as set A, and set B has the same median. Complete the cards in set B. Okay, so the median in set A is 18. It's the middle number. Oh, wait, no, it's not. I'm sorry. I totally lied to you. Okay, if we want to find the median, we have to put them in order. So 12, 15, and 18. That's the numbers there. And then the median is obviously going to be 15. So if we have 3 numbers over here for set B, 15 is going to be the median here. That means that 20, which they already told us, has to go over there. Okay, so now we said median, or the set B has the same median. Okay, we did that properly this time. Now, in terms of the totals, that's going to be 30. This is going to give us 45. And those 2 right there, they make 35. So we're missing 10. So the other 2 cards are going to be 10 and 15. They didn't say that we had to put them in order, so that's it. All right, I saw loads of people who did actually do this. I reckon a bunch of you made the same mistake as I did and accidentally said that the median was 18. Sorry. All right, question 11. I'm going to try to do this the calculator way since it is a calculator paper. The price of a DVD is £12. In the sale, the price is reduced by 25%. Work out the sale price. Well, if it's been reduced by 25%, it used to be 100%, and then they took off 25%, and now it is 75%. So what I'm really trying to find is 75% of 12. Now, because it's a calculator paper, that's going to be 0.75 times by 12, which is going to give me 9. Now, that's the way that I like to do the question, but I guarantee a bunch of you are going to want to do it another way. So let's first find 25% of 12. All right, you know what? I'm going to go with a whole non-calculator way that you love to do. So 50% is equal to 6, and then half that again, and 25% is equal to 3. So 25% of 12 is 3, and then if it's been reduced by that much, we started out at 12 pounds, we minus the 3, and we still end up with 9. Okay, I'm trying to think about other ways that people would do that. I'm sure that somebody somewhere is like, oh, well, 10% is 1.2, and another 10% is 1.2, and then 5% is 0.6, which is absolutely totally fine to do. You know what's going to happen when you add those all together? You're going to get 3, all right? And then you're still going to have to do 12 take away 3. Doesn't matter how you do it, you will still end up with 9. Question 12 took up a whole page and barely wanted us to write anything, but that's okay. Lee sells ice creams. The table shows the midday temperature and his sales for 5 days. He draws the scatter graph and line of best fit. write down 2 mistakes he has made. Well, this is good because we're usually pretty good at saying things that we've done wrong or saying things that people have done wrong. So we're going to try to make this look a little bit better. Okay, so let's check the points first. Well, I don't know. First of all, this does not look like a very good line of best fit. So the line of best fit is wrong. Okay, like that's the long and short of it. It does not go through enough of the points. It should probably go something like that, but you don't have to draw that. But yeah, the line of best fit is wrong. That's one mistake for sure. And then the second one, let's check his points. So 30 temperature and 180, that one looks fine. 26 and 150, that one looks good. 17 and 80, ooh, he only did that one up to 60. So mistake 2, day 3 is plotted wrong. You could make any comment about that, but it's 1 mark for saying about how his line of best fit is not right, and another one for saying about how day 3 has been plotted wrong. Question 13, we have some area and we also have some ratio. 2 shapes are drawn on a square grid. Work out the area of shape A to the area of shape B. Give your answer in its simplest form. All right, we're just going to count the squares up. So what has this got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So the area of shape A is going to be 24 squares. And then for shape B, I think because it's a triangle, people are going to do really weird things. You can see that the shapes match up. Like you can see that this shape here is going to fit in right here, but I don't want to count it like that. I want to do the base times by height divided by 2, just because I know that's what we have to do. So the base of this is 4, and the height of it is 3. So 4 times by 3 divided by 2, that's 12 divided by 2, which is 6. So the area of shape B is 6. Now 24 and 6 are both in the 6 times table, so we can divide both sides by 6, and we're going to end up with 4 to 1. All right, and then that's what they're looking for on the answer line in its simplest form, 4 to 1. Obviously, you could have gone 24 to 6, and then maybe half them both, and then those are both in the 3 times table, so 4 to 1. There's obviously lots of different ways to simplify your ratio. All right, question 14, we have probability from a table. Sweets come in 4 flavors: lime, orange, melon, and cherry. What is the probability that a sweet is cherry flavored? Well, this is a probability question, and all probabilities have to add up to 1. So 0.2 plus 0.15 plus 0.3 is going to give us 0.65. So those 3 together make 0.65, and 1 minus 0.65 is 0.35. So if we put that in there, that table now adds up to to 1 or 100%. What is the probability that a sweet is either lime or melon? So lime or melon, we can add those together. That's going to give us 0.5. And then lastly, probably one of your least favorite questions, because you guys do the weirdest things, and I really would like to know why, but that's okay. There are 200 sweets altogether. How many of them are orange? Well, the probability of getting orange, or the percentage of getting orange, is 15%, 0.15. So we're kind of looking for 15% orange, or 0.15 times by 200. Now the 0.15 came from right here, because that is the probability that we choose an orange sweet. So 0.15 times by 200, which is going to give us 30. There is 30 orange sweets altogether. All right, for question 15, we have some sneaky congruent oh, actually, no. Did they say they're congruent? They didn't. All right, it's some stuff about triangles. A and B are triangles. For each statement, tick the correct box to describe A and B. A's sides are the same lengths as B's sides. I would say those are always congruent because if two triangles are congruent, they could be congruent by the side rule. So I think the first one's going to be always congruent. A's angles are the same as B's angles. Now, I don't know about any congruency rule that says angle, angle, angle. Now, we could have, say, an equilateral triangle that's really badly drawn, but this is 60, 60, and 60, and I could have side lengths of like 1 centimeter, 1 centimeter, 1 centimeter, or I could make that triangle much, much, much bigger, and it could still be 60, 60, 60, so they could all have the same angles, but this side could be 3 and 3 and 3. So those two triangles are not congruent. Doesn't mean they're never congruent, but that would be a sometimes congruent. And then lastly, A is an enlargement of B with a scale factor of 2. Well, if something is much larger, they can never ever be congruent. So that one's going to be never congruent. Question 16 is by and large one of my favorite questions. I feel like I've put it on one of your tests before. It's just such a great question. There's a sneaky little thing in the very first line that people always seem to miss. So the diagram shows a square. One side is 7x minus 3, and the other side is 3 bracket x plus 1. They want us to work out the length of one side of the square. Well, what did you learn in primary school about squares? Hopefully you're shouting at me that they have all sides that are the same. And in algebra, the same just means equal to. So that must mean that 7x minus 3 is in fact equal to 3 bracket x plus 1. Now, if we did that step, we were usually pretty successful in the rest of the question. The other thing that people generally remember to do was to expand the brackets. So 3 times by x and 3 times by 1. So 7x minus 3 is equal to 3x plus 3. Now, if we got this far, we were usually pretty good at our algebra as well. We want to collect all the x's on one side. So I'm going to get rid of the smaller x over here and the smaller x over here and the x over there. So 7x take away 3x is 4x. I haven't done anything with the minus 3, so I'm going to keep writing that. 3x take away 3x is 0, and then plus 3. All right, now I need to get rid of this minus 3 so I can get the 4x by itself. So plus 3 and plus 3, and I'm left with 4x plus 3, which we actually saw on paper 1. Now you could divide both sides by 4, and we're going to be left with x is equal to 6 over 4, which is 1.5. Now, we're actually not finished yet. They wanted us to work out the length of one of the sides. Okay, so you can substitute it into either expression. You do have a calculator, so it shouldn't make much difference. I'm going to go with 7x minus 3. So it's going to be 7 times by 1.5 minus 3, which is 10.5 minus 3, which is 7.5. So one side length is going to be 7.5 centimeters long. Okay, if you had chosen to substitute it into the other one, it would still work. 3 bracket 1.5 plus 1, which is 3 times by 2.5, which is still 7.5. I do love that question. Who knows? Maybe you'll see it again in the March mock exam. I don't know. All right, question 17. Beth and Lynn each spin the same bias coin a number of times. The table shows information about the results. Beth spins 125 times, and the relative frequency that she's going to land, that her coin is going to land on heads is 0.32. And for Lynn, she spins the coin 80 times, and the relative frequency that she's going to land on heads is 0.35. How many more heads did Beth spin than Lynn? Now, this is very similar to our orange question a few questions ago. We need to figure out how many times did it land on heads for each of them. So for Beth, that is going to be 125 times 0.32. And that's going to give us 125 times by 0.32. That's going to give us 40. And then for Lynn, that is going to be 80 times 0.35, which is 28. Okay, so Beth landed on heads 40 times and Lynn landed on it 28. So we want to subtract those because they say how much more. So 40 minus 28 is 12. I think that most of us knew that we had to subtract something. It's just we weren't sure that we needed to multiply by the decimals first. And then for part B, Lynn says, my estimate of the probability of the coin landing on heads must be the best because 0.35 is greater than 0.32. Is she correct? Tick a box, give a reason for your answer. And unfortunately, she is not correct, okay, because it has nothing to do with the relative frequency. It actually has to do with the number of spins. Now, Beth did 125 spins, which is loads of spins, while Lynn only did 80, which is a lot, but it's less. So Lynn is actually wrong. So is she correct? No. Give a reason for your answer because Beth did more spins. Beth did more spins or more trials. Okay, the more times we do something, the more accurate it's going to be. So the fact that Beth did more trials is going to make her answer more accurate than Lynn's. Okay, it's always about the more trials. They've been loving this question a lot on the papers lately. All right, pie chart questions are one of my favorite questions because secretly they're just ratio questions in disguise. So let's see how this one goes. Question 18, the pie chart represents the number of rooms in houses in one part of Manchester. So they have houses that have 4 rooms, 5 rooms, 6 rooms, and 7 rooms. Apparently, they just have very big houses there. That's fine. Maybe they're not bedrooms. Maybe they're talking about like the lounge area it doesn't matter. Anyways, okay. The number of houses with 4 rooms is 940. How many houses does the whole pie chart represent? Okay, so first thing we need to do is find out what is this angle in here. So we need to add together the other angles. 168, 54, and 18. 168 plus 54 plus 18, which is going to give us 240. So those angles add together to give us 240. This is angles around a point, which is 360. So 360 minus 240 is 120. So this is 120 degrees. Now they tell us that that piece of the pie chart actually represents 920 houses. So 120 degrees equals 940 houses. Now, they wanted us to find out how many houses in the whole pie chart. The whole pie chart is 360 degrees. How do we get from 120 to 360? We times by 3. Now, this is why I like to just think about this as a ratio. So we can also times this side by 3. So 940 times by 3 is 2,820 houses. That is how I would do this question. There's probably other ways to approach this as well. I'm sure that the mark scheme had 3 alternative methods, but that is the way that I think is easiest and most straightforward and doesn't mean you have to learn a new skill. It's just using what you know about ratios. Oh boy, question 19. Did I ever see some interesting things happen here? But that's okay. Here is a map of Sardinia, which is the white part of it is the map, and then all of the gray part, as you can see, is the sea. So that is all water there. So the white part is the actual Sardinia, is an actual place, and then the gray part is the water. People can't live in the water, things can't happen in the water. It's just, you got to remember that. Work out the actual distance between Cagliari and Sassari. Give your answers in kilometers. So a lot of people did this first part really nice. They actually measured the distance between these two places. Oh, and I don't have my mark scheme with me, so I don't remember what it is. I think it was 7.5 centimeters. Okay, so most people measured it to be around there. It doesn't actually make much difference. We can figure it out regardless of whatever number you put. Now, it also says the scale is 1 centimeter on the picture represents 25 kilometers in real life. So 1 centimeter represents 25 kilometers. Well, I just fakely measured this to be 7.5 centimeters. So whatever I measure that side to be, I'm going to have to multiply to get from 1 to 7.5. is times by 7.5, and so I'm going to also multiply it by 7.5 over here. So 25 times by 7.5. I think that the answer could have been bigger than that, as in I don't remember what the 7.5 was actually supposed to measure to. I don't have the mark schemes with me, so I'm sorry. But when I multiply that, I get 187.5, and then that is it. They said give your answer in kilometers, so I am done. 187.5 kilometers. Now, in terms of the measurement, they're actually very generous. So whatever the measurement is, if you're pretty close to that, they will give you a mark for that. 1 mark for getting the measurement, 1 mark for multiplying by 1 mark for multiplying, I guess technically by 25, and then 1 mark for your final answer. Okay, so that's where your 3 marks come from in there. Now for part B, I had a few really good laughs of anybody who was able to draw the bearing. They did some very, very interesting things after that. So Mario's favorite beach is on a bearing of 165 degrees from Olbia. Draw this bearing and mark with a cross the position of the beach. So when we draw bearings, we always draw from north going clockwise. So that must mean that we start facing north, which is this way. And now I don't have a protractor with me, and it's very difficult to do this with a protractor or like on the screen. Oh, let me see. Hang on 1 second. Okay, I found a ruler. I'm not sure how well this is going to go, but we are going to try. Ooh, look at that. Okay, so this is not great. Oh, all right, so we'll just pretend because it's only going to do what I can do on here. So it says we would start facing this direction, facing north, and then they want us to measure our angle to be, if I measured it to be over here, right, that would be 180 degrees. We don't want that. We want it to be 165. So I'm going to move that ruler out for a moment, and you're going to think about if you had your protractor, you need to draw something that goes from here that's going to be 165 degrees. So like somewhere over there. But we're just going to try to make this a bit more accurate. Let me see what I can do with this. Can I get rid of that line? No, I can't, but that's okay. I can do this. Oh, there we go. Okay, winning. All right, let's bring back the ruler. All right. I don't know what this is measuring from, which is not what you want to hear at all, but that's okay. We're going to go with I'm just trying to think of the easiest way to do this without me completely cheating on here. I think this is as close as I'm going to get. It's fine. All right, so the angle would be from here, and it has to stop over here. Okay, this is the part that's more important than anything else. The blue line that I just drew, it has to stop there because this right here is where the beach is. All right, and they want me to make a little cross there, and it can't be randomly in the middle of the water. So people who did this, which I'm just trying to talk about, would like put the X over here, but that's not where the beach is because that's in the middle of the sea. It has to be something that is on the edge of the actual island, if you will. So it has to be on that white piece right there, so that little X there. All right, not my best ever with the protractor, but I did try. Question 20 is one of my favorite questions. I have used it in previous years. The 5th term of a linear sequence is 17, and the 6th term is 21. They want us to work out the 100th term. So I would go 1, 2, 3, 4, 5, 6. So those are my 6 terms. It says the 5th term is 17 and the 6th term is 21. And this is of a linear sequence. So this means it goes up by the same amount every single time. So this is going up by 4. So if we wanted to go backwards, it would go down by 4. So 17 take away 4 is 13. 13 take away 4 is 9. 9 take away 4 is 5. And 5 take away 4 is going to give us 1. So now we have a sequence 1, 5, 9, 13, 17, 21. I would then say, could you find the nth term of that? So we know it's going up by 4 every single time. So it's going to be 4n. And I like to do this by comparing to the 4 times table. So 4, 8, 12, 16. And then I'm going to subtract these. 1 take away 4 is -3. 5 take away 8 is -3. 9 take away 12 is -3. And I can keep seeing that same pattern. So this must be the 4 times table, take away 3. Lots of people have different ways of finding the -3. You do you. Whatever works for you, that's fine. Now, they want us to find out the 100th term. So 4 times by 100 minus 3, which is 400 minus 3, which is 397. Oh, I just love that question. There's something so much fun about it. I know, I'm a little bit sad, but anyways. Question 21. Harry and his sister Jess have some money in the ratio Harry to Jess 1 to 4. Harry has £7.35. They pay $16.99 for a present for a friend. Harry uses 1/3 of his money. Jess pays the rest. How much money does Jess have left? Okay, there's a bunch of places where we can start with this question. It doesn't matter necessarily which order you do it in. So I'm going to start with Harry and Jess have some money. Harry and Jess have some money in the ratio 1 to 4. Harry has £7.35. So how do we get from 1 to 735? That's times by 735. So you have to times the other side by 7.35 as well. So 7.35 times by 4. Jess has £29.40. Okay, so now we know Harry has 735 like they told us, and Jess has 29.40. Okay, they pay $16.99 for a present for a friend. Harry uses 1/3 of his money. So 1/3 of £7.35. 7.35 divided by 3 is £2.45. So Harry uses £2.45 of his money, but they spend $16.99. So $16.99 minus £2.45. So Jess has £14.54 left to pay. So Jess has to pay. All right, Jess pays the rest. Yep, cool. How much money does Jess have left? Well, we know, we worked out in the beginning, that Jess has £29.40, and we just found out that she has to pay £14.54. So 29.40 minus 14.54. She has £14.86 left. Now, it doesn't matter if when you do like the 1/3 of the £7.35, that doesn't actually make a difference. Some people did that first. Some people found out how much money Jess has first. That's absolutely fine as long as we get to the same answer in the end. Oh, and I just thought if we were trying to work out 1/3 of £7.35, I did 7.35 divided by 3. Okay, because when we're finding a fraction of an amount, we divide by the denominator. Question 22, another question that I think is really cool. I know that's so sad to say. I'm really sorry, but I thought it was neat. The Venn diagram shows some of the numbers of items in each set. The probability of A is 1/2. Work out the value of X. When you see the answer to this, you're going to be so upset. You really, really are. So the probability of A, that means this entire circle right here is equal to 1/2. Well, this entire circle here adds up to 50, right? So 30 plus 20 is equal to 50. And that means that the probability of A is 1/2, which is the same as 50 out of 100. So 50 out of 100 is also 1/2, which means that means the entire rectangle must also add up to 100. So we can go ahead and find out what's missing, which is going to be 30 plus 20 plus X plus 6 is equal to 100, because we can tell from this previous part that this was the probability of A. So everything in circle A added up to 50, and that is out of the entire total of the whole rectangle, which is 100, which is why I know that the entire circle or the entire rectangle has to add up to 100. Okay, and then combining things together, we have 50 plus 6. So 56 plus x is equal to 100. And then we can just figure out what number is left over there. We're just subtracting 56, which gives us 44. So x is equal to 44. Oh, I really did like that question. It was in the higher paper as well. I just thought it was really neat. There was a bunch of other ways you could work it out, but I think that's the nicest one. 23 maybe looks more complicated than it really is. A runner starts at A. She follows this route. She goes from A to B, and then B to C, and then C to D, and then back to A, okay, which is the whole outside of the shape. 3 of the distances are shown on the diagram. You've got 1, 2, 3 of those distances. Work out the distance in kilometers from D to A. So they just want this last piece right here. They just want to know how big this piece is. And they even told us use Pythagoras' theorem to show that the distance in kilometers from D to A is somewhere between 3 and 4. All right, here we go. Let's get rid of all this stuff so we can figure this out. So they said very nicely, make sure you use Pythagoras. Okay, well, Pythagoras helps us to find the missing side in a triangle, but we need 2 of the sides. So we're actually going to have to start over here. We can find this side, that blue side, by using these 2 sides here. Now, this side over here is actually the hypotenuse. It's the longest side, and the blue side is one of the shorter ones, so we're going to have to subtract. 2.5 squared minus 2 squared. 2.5 squared minus 2 squared, which is going to give us 2.25. And then remember, that's not actually how long that blue side is. When we're squaring things, we have to undo that. So the square root of 2.25 is 1.5. And so now this blue side right here is 1.5 kilometers. Now that we know that, we can go ahead and in this triangle over here, we can find the distance from A to D. And this side right here is opposite to the right angle, so this side is going to be the hypotenuse, which is going to be the longest side, so that means we're going to square the other 2 sides. So 3.4 squared plus 1.5 squared is 13.81. But that's not us finished. Don't forget, we have to go ahead and square root that answer. So the square root of 13.81 is 3.716. There's some more decimals after that. I'm just going to call it 3.7 because 1 decimal place is plenty. Okay, 3.7. Now remember, they said in the start of the question that she walks. I need a different color pen. Ooh, I don't know what color. Ooh. Sorry, just trying to decide. Ooh, wait till you see this color. Okay, so they say she walks from A. That's not the color I chose. Ah, sorry, you will really appreciate this though, you will. Okay, let's choose this one. So she walks from A to B. Thank you, that's pretty. And then she walks from B to C. And then she walks from C to D. And then she walks from D back to A. So we need to add 3.4 plus 2.5 plus 2 plus 3.7. All right, 3.4, 2.5, 2 kilometers. That's like 2.0. It doesn't matter. You're going to put it in your calculator anyways. And 3.7. Oh, hang on. I got way too complicated. Ignore all those things I said. Who cares about the pink color? It doesn't really matter. I got way too excited about this question. Show that the distance from D to A is between 3 and 4. I already did that like 5 minutes ago. So sorry. All right, 3.7. We're done. Sorry, got a little carried away. Did they give us a part for the answer line? No, we're done. All right, and the final page of the exam. Question 24a, write down the equation of a line parallel to y minus 3x is equal to 1. Well, all lines are in the form y is equal to mx plus c. So if we rearrange this, this is going to look like y is equal to 3x plus 1. If two lines are parallel, then that means they're going to have the same gradient. So our new line also has to say y is equal to 3x, and then you can put any number at all that you want over here. You're just not allowed to use plus 1. So I'm going to go with y is equal to 3x plus 2. Okay, you can literally choose any number at all that you want as long as it has y is equal to 3x. And then lastly, 24b, a straight line has a gradient of 5. So that means it's going to look like y is equal to 5x plus something else. And it passes through the point 3, 7. Okay, so we can get rid of this option here because that had a gradient of 3. And we can get rid of this one because it also has a gradient of 3. The next one says it has y is equal to 5x. Well, we could just check if the point 3, 7 fits on that point there. So this is x is 3 and y is 7. So we can go ahead and substitute that in. 5 times by 3 gives us 15. It does not give us 7. Okay, 7 is not equal to 15, so that is not our equation either. So y is equal to 5x minus 8. You can always check 5 times by 3 minus 8 is going to give us 15 minus 8, which is going to give us 7, which is what they wanted for our coordinate. All right, I hope you enjoyed that. I'll see you back here for paper 3. Bye.